Picture yourself standing on a quiet Jordanian hillside. The sun's warm, the sheep are grazing, nothing seems out of the ordinary. Then, archaeologists lift a heavy stone slab and discover a tangle of skeletons, men, women, and tiny children, packed shoulder to shoulder in a cramped chamber. No gold, no weapons, no royal regalia, just one haunting question. What wiped out an entire community almost overnight? Here's the thing. At first glance, the scene looks like a battlefield cleanup, or maybe an earthquake burial. But when researchers looked closer, the bones wouldn't cooperate with either story. There are no sword gashes on skulls, no ribs crushed by falling stones, no signs of people dying mid-escape. Instead, bodies arrived in layers, almost like tides washing onto shore. A cloak pin here, a child's bracelet there, everyday objects that feel heartbreakingly ordinary. These weren't soldiers, they were neighbors. First signpost, timing. Radiocarbon dating put the death smack in the mid-6th century CE, the very moment Byzantine writers start whispering about a terrifying new pestilence. Second signpost, location. The grave slices right through an old, abandoned water cistern. Imagine that, a structure built to keep people alive, repurposed in desperation to hold their dead. Now, how do you turn a hunch into hard proof? You go microscopic. Researchers drilled into the dental pulp of several skulls because teeth act like tiny time capsules, and they sequenced any genetic fragments still hiding inside. What showed up? The unmistakable molecular fingerprint of Yersinia pestis, the bacterium behind bubonic plague. Bingo! Detecting that pathogen in multiple individuals transformed a vague, mysterious sickness into a clearly diagnosed outbreak. Suddenly, this small farming community slots into a much bigger catastrophe chronicled from Constantinople to Alexandria. Ships docking with sick crews, carts piled high with corpses, entire households gone within a week. Until now, some scholars shrugged those tales off as medieval exaggeration. But here, in one overcrowded tomb, the scale of loss is literally written in bone. Let's zoom in on the people themselves. The demographic mix, infants, teenagers, adults in their prime, and elders, matches what we see in other plague cemeteries across Eurasia. Fast-moving disease kills broadly. Famine usually spares the strongest. No battle scars, no chains, no mass of slaves. Just villagers caught in the same lethal sweep. Body positioning adds another clue. Typical 6th century burials are neat and individual. Heads west, arms crossed, plenty of room between graves. Not here. Some folks lie sideways, some partially on top of others, feet pointing every which way. That chaos shouts one thing: people were dying faster than ritual could keep up. Archaeologists treat a scene like this the way epidemiologists tackle modern outbreaks, but with soil instead of spreadsheets. They map where each skeleton lies, which bones belong together, and how the layers stack. Then they compare notes with other crisis burials around the Mediterranean. In some places, you see tight family clusters, parents curled around children, suggesting households perish together. Sites like Beit Ras, though, are wall-to-wall bone, hinting at repeated waves of death before survivors could regroup. Even seemingly tiny details carry weight. Take tooth enamel. Its chemical makeup can reveal whether someone grew up drinking local water or arrived from far away. That tells us if the dead were longtime residents or travelers caught on the road. Bone chemistry can also flag earlier hardships, famine, hard labor, chronic illness, that might have weakened immune systems long before plague sailed in on the wind. All these strands, DNA, burial layout, chemical signatures, braid together into a wider picture of how disease rippled along trade routes and social networks in late antiquity. Think of it as a forensic time machine. Each data point pulls the camera back another step, from a single tomb to an entire world under strain. So, why should we care 1,500 years later? Because this grave is more than a morbid curiosity. It's a stress test frozen in stone. By replaying the events of the 540s, matching skeletons to shipping routes, pathogen DNA to climate swings, researchers can model how communities shatter or adapt when an unfamiliar microbe arrives. Swap sailboats for airplanes, and the questions feel uncomfortably current. Let that sink in for a second. Recap and takeaways. So here's what we covered today. McShirley Artmite for discovery. A hillside chamber in Jordan stuffed with skeletons. No weapons, no earthquake rubble. Just ordinary people buried in a rush. Diagnosis. Radiocarbon clocks and dental DNA pinned the deaths to the mid-6th century and identified Yersinia pestis, the bubonic plague bacterium. Clues in the layout. Mixed ages, haphazard positions, and a reused cistern all point to a community overwhelmed by a fast-moving epidemic. Bigger picture. Comparing this grave to others across the Mediterranean links a small farming village to a pan-Byzantine pandemic once dismissed as legend. Modern echo. Studying how that ancient network cracked or held helps today's planners imagine how our own global systems might flex under the next microbial surprise. The empowering part? Knowledge is preparedness. Every tooth, every bone, every soil sample from Beit Ross sharpens the playbook for future outbreaks. The past isn't just history, it's rehearsal. Thanks for listening, and remember, the next time you hear about an archaeological dig, you might be looking at tomorrow's public health lesson buried in yesterday's ground.